Hello everyone. Welcome to your lecture. Today we'll be talking about for loops more. I forgot to mention, I've been using this term signature for a while in header, and I realized I never sort of gave you like an actual definition of this. So when I talk about a function signature, that just means what the function is taking as input and what it's taking as output. So the following function includes a signature. So this is the function name, and the signature would be the rest, right? So we can always define a function without a signature, but having its signature there is useful because you know what it takes in and puts out. Recall further that we were using loops last week to accumulate values. So I could say that sort of answer was empty and then loop through A, B, C, D, E, F and accumulate that value, and by the end of it, answer would be A, B, C, D, E, F. Now, because we accumulate so often, there is a short form for accumulation, which I didn't show you last week because I didn't want to overwhelm you with new stuff. We can, instead of writing answer is equal to answer plus x, we can just write answer plus equal x. Right? Those two things are equivalent. So either is fine, but you should know this. Right, because I think on your exams and midterms, this short form is fair game. To be more explicit about what short forms you have, you can do this with basically all of the arithmetic operations. So x plus equal y is equivalent to x is equal to x plus y. X times equal y is equivalent to x is equal to x times y, and so on. So just be aware that those short forms exist and use them if you'd like, but certainly know how they work. So let's use this new fancy accumulator short form to write a function that removes spaces from a string. This should be a pretty simple warm-up. Remind me, can you guys see everything? Okay, good. I'm just going to do what I normally do. I'll just create a Monday piece of code. Launch it here. What was I supposed to do? Define something that removes spaces. I'm going to take C's, which is a bunch of characters. I'm going to return a string. This function is going to remove spaces from the string C's. A couple doc examples here. I can say A, B, C, and that should return A, B, C. But also note that I never indicated that we had any operating assumptions. So this should also return this. And also remove space should work on the empty string. Okay. So I'm just going to start, gonna just create an accumulation variable, this answer. And I'm going to walk through my string in a typical way. I'm going to say for each character in the string. If C is a space, then we're just going to skip it. Right? Okay, I don't want to. If this is not equal to a space, so I don't have to show you what a continue is. Do we have continue? Yeah. If C isn't a space, then I should accumulate that value. Else do nothing. And then eventually I should be able to return the answer. Let's just print the answer here just to see how this is working. So let me go into Python here. Let me read in Monday. Let's remove spaces from one of our doc examples. A, B, C. All right, so you see, first way through the loop, it assigned A, then AB, then ABC. And then it returned. I could code refactor this if you wanted. I could say something like answer plus equals C if C is not a space. Else, oh wait, no, I can't do it this way. Sorry, I can't. The nature of the way that I wrote it means that I want to add something or skip. So, oh wait, no, I can. I can do this. I just have to do a little trick. Okay, so answer plus equals C if C is not equal to a space. Else, just add nothing to it, right? We have sort of the empty string, right? And that should work in the same way. Perfect. So here's a simple code refactor. Just this here. Okay. So I'm going to throw everything in one big file on the website so you don't have to worry about copying down the code that I'm writing today. There's another type of variable that's like in the same class as accumulator variables, and we call this a counting variable. So sometimes instead of accumulating a value, or sometimes the value we want to accumulate is in fact the number of something. So let's write a function that counts spaces from a string. And how do we do this? Well, let's go here. Let's say count spaces. I'm going to take C's, which is a list of characters, which is a string, return a string. And I'm going to count the number of spaces present in C's. And let's see. Count spaces ABC should be 2. And maybe count spaces in here is 0. So now I'm going to create, well, I'm going to have an answer variable, and its default, its initial value should be 0. I'm going to walk through my string, and I'm going to say if the C is a space, then I'm going to increment answer by 1. All right, so I can print what we have, what C is, and what my answer is. So let's count spaces in A, B, C. All right, so it found a space, and it set answer to 1. And then it found a space, and it set answer to 2. Right, so remember, this line here is equivalent to answer equals answer plus 1. So tracing this code, count spaces is going to be given a string, and then count spaces is going to initialize some counting variable to 0, because we've so far have counted 0 spaces. Then it's going to walk through the string, character by character, and if we encounter a space as one of the characters, it's going to trigger this if, and it's going to increase answer by 1. Right? So I can refactor this as well. If we choose, I can say answer plus equal 1 if C is not equal to a space, else it gets plus equals 0. Right? I don't change the accumulator at all. And we can see that it still works. Any questions so far? This is sort of just warm up. Okay, so we have accumulator variables, which help us build an answer. We have counter variables, which are specifically accumulating plus ones, a count. There's one more variable that we use sometimes, and that's a variable that stores the current or some candidate. So if we're trying to find the largest member of a group, we may do it this way. We may say, okay, the current largest member of the group is the first thing. Look at the second thing. If the second thing is larger than the first thing, then the second thing is the largest member of the group. And then look at the third thing. If the third thing is bigger than the current largest thing, then replace it, right? So we're always going to be, we always have some current largest object, which we're going to use to compare to everything else. So write a function that returns the largest character from a string. How could we do this? Well, as I just described. Define largest character. Let's take a string. Let's return a string. What is this going to do? This is going to return the largest. Well, I'm going to put some quotes around largest, right? By Unicode ordering. Character from C's. So we can have something like largest character of exclamation mark, $, A, and A. And I think the largest character from that would be A. We can also have the largest character from FFFFF, and that should be F. Okay. So I'm going to create some answer here. And the question is, what should I set it to? So some problems here, right? I need the first candidate. Like I need some default value for answer. So when I was accumulating strings, the default value for answer was empty. right? When I was counting something, the default value for answer was 0, because you start counting from 0. What should I start comparing with, right? It needs to be something that's smaller than every other character. Okay. Any ideas? Okay, so suppose I make answer equal to like the first thing. What problem do we have then? What happens if I say, okay, so my first candidate is this? What problem does that immediately introduce? You got to think now, right? Because, oh yeah, you in the back. String could be empty. You have to start thinking like programmers. And you have to start thinking that every other programmer has it out to get you, right? And every other programmer is going to try to break your code somehow, right? So you have to ask yourself, if I wrote code like this, how could another programmer break it? Right? So we can't simply set it to 0, the 0th element, because it doesn't exist. So for the time being, I'm going to say assumes that C's is a non-empty string, right? Just so we don't have to check for that. But later on, I'll show you how to resolve this properly. Okay, so now I can say answers is the first element because it's guaranteed to exist. And now what do I want to do? Well, I say I want to walk through the rest of the string, and I want to say if C is greater than my answer, or maybe a better word for this is current largest. Right? If C is bigger than the current largest, then the current largest gets C. Right? Else we don't touch it. And then in the end, we want to return the current largest. So let's first check that this is readable by Python, so I didn't write any errors. Let's look for the largest character in hello world. I think that should be W. Current largest. Okay, W. Largest character. So I never specified anything else about... Okay, so first of all, if I give it an empty string, it's going to fail. It failed. I also never specified that I needed small case characters or characters at all. Right, so this should work. Perfect, right? So don't add more restrictions than is there. All I said here is that it's going to return the largest character by Unicode. And I mean all of them. I mean including smiley face. If I wanted to code refactor this, I could say this. You know what? I'm not going to code refactor it. I think that's just making things more confusing. This is perfectly fine Python code. So let's trace this, right? So if I give largest character a list of characters, what's it going to do? It's going to say, okay, the largest character, at least the candidate for the largest character, I'm going to assume it's the first thing in the list. Then I'm going to go through the list and say, if this character in the string is larger than the current largest character, then the current largest character should become that thing I just looked at. Right? So at every step of the string, we should have the current largest character of everything that has been checked. Right? So if there was 10 characters in our string and we looked through the first 5, we would have the largest of the first 5 characters, then the first 6, 7, 8, 9, 10. Right? And at the 10th, we'd have the largest character among the whole string. So I'm going to throw this in the big strings Python file. I'm going to put it on the course website. But I noticed no one complained about writing this in the first place. There's actually a much easier way of writing this. Right? There's a built-in, right? Right? That works already. Right? This built-in max-min works. Right? So sometimes I'm going to rewrite some simple built-in function just for the purposes of demonstration. But this largest character function is sort of overly complicated. But I think Max would do something similar, right? So just because something's a built-in doesn't mean we're not going to ask you how to write it. So it's totally fair game on your midterms or exams to say Max is a built-in function in Python. Right? Write the code for Max. Right? So don't get too used to using these built-ins because it may end up screwing you. I don't know a softer way of saying that. So how now could we write a function that removes all of the largest characters from a string. Right? This is going to have to happen in a two-step process. So any ideas? Right? Just a loose description of how we could remove all the largest characters from a string.
One for loop to find the largest character, and then another to go through it again and remove that character.
Yeah, and a procedure to bind them. Just like Frodo's rings. That was the correct answer. So we need two loops. Or we need to do two things. We need to run through the string to first determine the largest character. Right? We're going to have to look at the whole string. There's no skipping that. And then we're going to need another loop to accumulate and skip over the largest character. So let's be lazy. That is to say, good programmers. Remove all largest. Okay. So I'm going to define remove all largest from C's. It takes a string. It's going to return a string. I'm going to say something like returns a new string with the largest character from C's removed, with all the largest characters from C removed. So something like remove all largest from AAA. That should return what? Well, specifically what nothing? Nope. Empty string. Yeah. Remove all largest from Hello World. Hello World. Yeah. Okay, so we need to do this in a two-step process, right? So I'm going to create an accumulation variable, call it answer. We're going to start accumulating from nothing, right? Let's create a variable for the largest character, and that is going to be the largest character from C's, right? So we're just recycling code that we've already created, right? So find the largest character. And then what do we want to do? We want to say for C in C's, accumulate. And when do I accumulate? Well, if C is not the largest character, then I want to accumulate on answer. Else I just want to skip. And then I want to return the answer. So let's see if this works. Perfect. Remove all largest from Hello World. Dun, dun, dun. What did I do? Oh, okay. So my code is working. I forgot that W is smaller than everything. So what did it end up removing? R. Okay, so I should do this. Okay, perfect. That's a good feeling when your program is working properly, but you did something wrong with the doc string. Okay, so that should be better. Okay. Okay, so that was combining two things, right? We had to do a search for something, and then we had to do an accumulation based on that search. Now, the finding the largest character is going to be something that we're going to study a lot more closely. Not necessarily finding the smallest character, but finding the largest or smallest something from a group of something is a very, very important computer science topic. Like Google is basically a company who has really, really good search. Right? You can imagine trying to enumerate through the entire internet to find something. You can't just walk through it step by step like we're doing. Right? This is called naive type of implementation. A naive implementation is there's obviously an easy way to do the problem, which is going to take a really long time to compute. Right? So this would be one of those cases. You could imagine that if the largest character was like the entire text of the, I don't know, what's the longest book? I don't know, the Bible, right? That may take a little bit of time to run through. So search is going to be something that we're going to be extremely interested in. So I'm going to add this to the course website. What's one single, suppose we had a huge string. What would be a condition where we could actually stop searching? Suppose we're just working with A through Z. Right? And I said, find me the largest character in this string. There's a million of them. There's a million characters. What's one optimization that could be made in that setting? Suppose you found, oh yeah. Is that how they're ordered? I think, no, Z would be the largest. Yeah, and so you had it backwards, right? So if I was like searching a million characters and I find a Z, I find the thing that is the largest possible thing. I can say, oh, I found the thing which is the largest possible thing. Stop. I don't care about the remaining 900,000 characters. You're never going to find anything larger than a Z, right? So these little observations are going to be very helpful for us as computer scientists, right? Just trying to eke out any, that's called an optimization, right? And this is the whole name of the game. Strings is Booleans, right? So this is something I never pointed out last time. So what happens if I ask for the Boolean value of a character? Python is funny in this way, right? You wouldn't think you'd be able to cast a character into a Boolean. The first part of what you said is correct. The second part is not. Right? So you get true is correct. Yeah.
Does that have something to do with the binary of the Unicode?
It's much easier than that. Yeah. No. These are all really good guesses. We have things in Python. We have collections in Pythons, whether they be collections of characters, which turns into strings, integers into lists, sets. Anything that's a non-empty group will evaluate to true. And anything that is empty will evaluate to false. This is very useful for case checking, right? Because you don't check if a list is empty. You just ask for its Boolean value. An empty list has the Boolean false. So hello is a non-empty string, so its Boolean should be what? True. The Boolean of the empty string should be false. Empty string is less than A. That's true. In fact, empty string is less than the Unicode character at 0. What does that mean? Whoops. Hope none of you can read very quickly. There's no character at -1. Right? The Unicode characters start at 0. So if I know that the empty string is less than the Unicode at 0, the empty string is basically minus infinity. It's a character that's smaller than every other character. So this is actually the solution to the problem from a few functions ago. Remember when I was here? And I said something like, where was I? Remove spaces. Where's my find smallest? Oh, largest character, right? This won't work on the empty string, right? Because I insisted that my first candidate was the first element. Well, what can I replace this with now, safely? Empty string, exactly. And now I can actually remove this condition. All right, so check this out. Largest character, what is the largest character in A? A. What's the largest character in A, B, C, Z? C. What about this? Right? What about empty? Empty. Right? So I said, okay, my first candidate is the smallest thing that it could possibly be. Right? So when you're, suppose, this would be easier to describe using a set of integers, but I don't have that yet. But if I wanted to find the maximum value in a set of integers, the first thing that I should set my candidate to is -infinity. Right? Because as soon as it's non-empty, the list, okay, the first thing is going to swap with it. So you may have to think about this a little bit, but it is important that the empty string is basically the bottom of the Unicode ladder. It is the smallest possible character because it doesn't exist. Right? So it is true that the empty string is less than the unical character at 0. What about this? Is this true? Is there a difference between the space and the empty string? Yeah, so it should be the case that this is true. I wonder what is the ordinal of this? Oh, geez, space is 32. It's not even close to the beginning, right? So just keep that in mind, right? That the string of a space isn't empty, right? The length of this is 1, right? The length of this is 0, right? So they can't be the same thing. They have different lengths, right? So we're going to try to trick you, right? So if we say something on the test, are these things equal? You're going to say, no, they're not. Okay, so there are two things I want to show you, and it's this for all symbol and this for exist symbol. You don't have to understand or remember the mathematics of this. I'm just showing you the mathematics because it's interesting, and some of you may need it soon or next semester. So you need to understand the code, but you don't need to understand the mathematics. Right? So that being said, in mathematics, we have this upside down A, right? And this upside down A is a short form for writing the phrase for all, for every, right? And it's used to denote that every member of a set satisfies some condition, right? So this statement here reads, for every x in the set X, the predicate Px is satisfied, right? That is to say Px is true. Remember we had these binary functions or unary functions that went to true or false? In the case where x is enumerable, or in Python speak, iterable, right? That is, we can just say this is the first element of x, the second, the third. The condition means that it is the case that Px0 is true, and Px1 is true, and Px2 is true, and so on, right? For every, it means that for every member of the set, the member satisfies some condition. Right, so I can write a more precise, or I can write a more specific statement that says, for every x in x, right, for every maybe character in a string, we have that x is less than k. Right? Oh, this should be k with quotations. So it is true that for every x in ABC, x is less than k, right, because a is less than k, b is less than k, c is less than k. And it's false for x equals to this string, right? Because j is less than k, but k is not less than k, right? And since not everything satisfies the condition, this is false. Okay, so first, I want to write a function foo, which takes x, the string, and then checks this condition, right? That is, checks to see that x is less than k. All right. So definition foo, it takes x, a string, it returns a Boolean value. And what are we doing? Here we are checking condition 1 from slide 711. And it should do something like foo of ABC is true. And foo of JKLM is false. Right? Whoops. Okay, so how can I do this? So I want to confirm that every member of x is greater than k. Right, so I'm going to step through x. So for every x, small x in big X, I want to check if x is less than k. And if it is less than k, we're fine. So what I should actually be checking that this is not the case. If it is not the case that x is less than k, what can I do? Return false, right? Because as soon as I find something in the set that doesn't satisfy the condition, we're done. These are conjunctions. These are ands. So am I done? What happens if I make it through every member of x without returning? What does that indicate? What can I assume here? Well, okay, so we have one guess, else what? Okay, what's going to happen here? Is this correct? Yeah. This is only going to check the first character and then return. Right? So we can't use an else. Right? Because we need to check every single character. And as soon as one of those returns trigger, we're done. Right? So this is going to go into the function. It's going to pull the first character out of X and then just render a decision based on that. So can't do this. It's closer though. Where should I put the return?
Outside the for loop.
Right, outside the for loop here, right? Because at this point, we know there is no x in x such that not px, right? Right? If it never threw false, the only thing that can be true is that every member of that set satisfied the condition. Okay, so let me read this in. Let's check this. So for ABC, that should be true. For JKLM, that should be false. Right? And let me print something here. Right? I found this in X, and it's not, whatever. I found this in X. Right? Dot format X. I found K. Okay, so it's saying it found a K in JKLM, and that K is not less than K. Okay, maybe I'm going to take that K out and put in a J. L's not any better. My God. O. Okay. Now it's saying I found an O in X, right? And O is not less than K. So I threw false. Right? So it doesn't check M, right? It immediately escapes as soon as it finds a false. Okay, so we've done that one. I am running out of time. This is not the definition for all. This is the definition for there exists, right? So I gave you an upside down A, which I thought was cool. Now I'm going to give you this backwards E. Right, so this backwards E is a symbol in mathematics that's short for there exists or there is a member, right? So in this case, if X is enumerable, that is, if I can count the members of X in order, there exists X in X such that Px is true when there is some element of the set for which P evaluates to true. Right? So it's going to be the case that Px0 or Px1 or Px2 and so on. So we're going to check the same thing from the last slide, except I'm going to replace the upside down A with a backwards E. All right? So now I want to see, is there an X in the set such that X is less than K? All right? So it is true that if X is A, B, and C, there is an X that's less than K because A is less than K. And it is true, not false this time, that X is equal, that when X is equal to JKLM, that there is a letter less than K because J is less than K. Okay? So now I want to write a function that checks the condition of 2 like we checked it for 1. Right? So let me write bar, def bar, takes a string. Mondays, am I right? Okay, this is going to return a bool. This is going to checking condition 2 from slide, I think 13. Yeah, 13. It's going to take, I think, for both of these, it's going to return true, going to return true. So when you're writing these doc strings, it's usually good practice, if you're returning a bool, it's good practice to give an example which returns true and false. So can someone give me a string which would return false for this condition? Right, the condition I'm checking is there exists X in the string that's less than K. Huh? OPQ. Right? There is nothing in that. There's not O, not P, not Q is less than K. So this should return false. So it's going to be very similar with just a small difference. I'm going to check each element of X. And if X is less than K, which is the condition I'm checking, then what do I do? Yeah, right? I'm searching to see if there's any character in X that satisfies this condition. Right? So if I find it, I can say, yep, I found one, return true. No need to continue. And in a similar way from foo, if I make it through the whole list without finding a single character that will trigger this return true, right, then it's false. So let's read this in. Let's check bar of ABC. So this should return true if one of the characters A, B, or C is less than K, which is true. This should return true if one of the characters is less than K, returns true. And this should be true if one of the characters is less than K, which will be false, right? So this condition checking is important. Like, so I want you to study the bar and foo example and like do the stuff from your labs this week, right? Because this notion of searching a string for something that satisfies a condition, that's important. Okay, so I have 7 minutes. In the last 7 minutes, I'm going to show you something that you don't need to understand or know. This is a little bit of advanced material. I just thought it was cool to show you this, right? So don't freak out if you can't follow. I don't want to check a single condition, right? This foo in the bar I just wrote, that's wasteful code, right? Because I want to be able to reuse it on other things, right? So it's better if I could write code def for all that takes X a string, but also takes a P a function, right? So there's just one thing here I have to do that I don't want to have to teach you guys how to do it, but I can't do it without it. So I need this, right? I want to write this, but this function doesn't actually exist as a type. You can make it a type by importing from this library. So don't worry about it. I'm just going to put this, right? Just so we can have our function signature correct, right? So this is going to check for all X in X, we have PX. So I'm just going to do maybe for all ABC. Then I have to define P, which takes X, a string, and returns bool. Maybe this just return X less than K. So the same condition, then I can give this P. Right? I can write the exact same thing. I can say for X in X, if not PX, then I can return false. And else, well, not else. If this whole thing runs, then I can return true. So I can just do something like this. That's not what I wanted to do. I can read in my Monday code. I can say for all, well, I'll first define a P, which takes an X, a string, and returns a bool. 1, 2, 3, 4. X, return X less than K. And now I can say for all ABC, do we have P? True. For all A, B, D, E, F, do I have P? That's true. Let's try to false it out. Great. Okay, I'm going to quickly do the other one. Right? So this is going to be there exists. And it's going to, if P return true, if else, if it gets through everything else, it returns false. So there exists. You know what? You can play with it. There was one thing I want to mention that I didn't quite manage to get to. I wanted to check this condition. For every X in X, there is Y in Y such that X is greater than Y. Right? So maybe as homework, you can try and test this condition, but don't try too hard. Because I wanted to show you that I could tie together, that I could write statements like this. But I don't have time to go through it properly. Right? But maybe give this a look if you'd like. Otherwise, just go to the labs. And if you guys have no objections, maybe Friday I can teach you about neural networks, if you want. Yeah.